Chapter 9. Chapter 9 looks at CVP analysis, or cost volume profit analysis. Cost volume profit analysis is a short-term operating decision analysis looking at profit, break even. When we're looking at CVP analysis, we're looking at the relationship between operating profit and variable costs, total selling costs, total fixed cost, the unit selling price, our output level, and our sales mix. Our CVP model analysis has several different equations. So we have that operating profit is sales minus total cost. But in CVP, we're going to look at the relationship between variable costs and fixed costs. So when we're breaking that up, we have units sold times their selling price minus units sold times their variable cost per unit minus fixed costs. When we look at a single product, we normally look at this where we have the operating profit before tax equals units sold times the selling price per unit minus units sold times the variable cost per unit minus total fixed costs. We also have the contribution margin for total and per unit. The unit contribution margin is the sales price minus the variable cost. The contribution margin ratio is our contribution margin divided by sales price. Okay. The unit contribution margin is the increase in operating profit for a unit increase in sales. And the total contribution margin is our unit contribution margin times the number of units sold. For a contribution margin ratio, this is contribution margin divided by unit sales price. When we look at a contribution income statement, we're going to show that fixed costs and variable costs, we classify costs based on their cost behavior. So first, we list sales revenue, and then we list variable costs. Revenues minus variable costs equals contribution margin. And then contribution margin subtracted from fixed sales costs equals our operating income. So rather than looking at our cost type, product versus period, we look at our cost behavior, fixed versus variable. This allows us to show how the effect of a change of sales would have on operating profit. So either increasing or decreasing the amount of sales. This helps us make strategic decisions. Okay? So this process is most important for cost leadership firms during the manufacturing stage, where differentiated firms use CVP analysis to look at profitability and desirability of new products and features. We can also look at how different things, such as marketing campaigns, can increase our sales volume and also affect our costs and profits. We're going to look at life cycle costing. The CVP analysis helps us to determine whether a product is likely to achieve its desired profitability at all. What are our potential marketing and distribution channels? What kind of compensation plans we want to offer our management? We can also look at target costing. And in target costing, we see what the market will pay versus what our manufacturing cost is. And in target costing, we're trying to drive our manufacturing costs under a specific amount in order to achieve a specific profit. We ask a lot of questions when we're doing CVP analysis. CVP analysis is also sometimes called what if analysis. What if we do this? What happens if we do this? What happens if we make this change? This is just a general list of questions that we might be able to answer with CVP analysis, like what amount of sales is needed to achieve a specific operating profit? What is the required funding level for a governmental agency given desired service levels? What do we need to hit? What's our break even in sales? So for break even point, we can determine that in two ways. So at break even, this is the point where our revenues equal total costs and our profit is zero. We can determine that with break even in units sold, or what is the break even in sales dollars. The break even in units looks at fixed costs divided by contribution margin per unit. So the break even in units is fixed costs divided by our contribution margin per unit. Contribution margin, as you will remember, is sales price minus variable cost. This is the gross margin we have left to contribute to paying fixed costs. The break-even sales in dollars is fixed costs divided by our contribution margin ratio. Looking at this example, they want to perform a break-even analysis given their following expected results for 2019 and 2020. So we have projected fixed costs per year of $60,000 in 2019. We have a planned selling price of $75 per unit, variable cost of $35 per unit, planned production of 2,400 units. So we look at what are our total variable costs, what is our total contribution margin. Our contribution margin ratio is 53.33%. So our fixed cost, 60,000. We have an operating profit where we see that it's 8,000. So 8,000 equals 0.533 times $15,000. So our change in sales, $15,000. When we're trying to look at our break even in units, we take our fixed costs divided by our $40 per unit contribution margin. So as we can see here, our total fixed cost for the year, $60,000. That means that our fixed costs per month are $5,000, 60,000 divided by 12. So 5,000 per month divided by $40 contribution margin per unit tells us that in order to break even, we need to sell a minimum of 125 units per month. Our break even in dollars is determined by taking that 5,000 a month fixed cost and dividing it by our 53.33% contribution margin ratio. We then see that we need $9,375 a month in sales. We can also take our break-even number in units times our unit selling price. We will get the same amount. The CVP graph illustrates how the changes of revenues and total cost change as output or sales volume changes. So we can see our break-even point where we operate at a loss and where we have positive operations. We also have a profit volume graph that shows how the level of operating profit changes as our output or sales volume changes. We'll look at these two graphs on the next two slides. This is a CVP graph. We can see that we have a break-even point of 125 units. So on a CVP graph, our costs, where they cross over, where our costs and our revenues cross over, is the point of break even. Anything below that break even point is a loss, and anything over that revenue point or that break-even point is revenue. So our total costs have a linear relationship and our total revenues have a linear relationship. At 0 units, we have $0 in revenues. At 125 units, we cover our 5,000 in fixed costs and our unit variable costs. This operating profit graph shows where we have profit and losses. When we're making profit planning, then we can also look at how we determine what is our before tax profit. So the symbol showing before tax profit. For before tax profit, instead of just looking at fixed costs divided by contribution margin, we would take our fixed costs plus our desired profit and then divide that by our contribution margin per unit. So here we have, with our $60,000 a year in fixed cost and a desired profit before tax of $48,000, a contribution margin of $40, we need to sell 2,700 units per year in order to meet that desired before tax profit.